So give me a moment, gentlemen, while we get set up. I'm just taking attendance as I let people in. And we're probably just going to go ahead and get the party started once I'm done with this. It does seem like it's trying to lag. I did my best to minimize processes so it like would minimize the lagging, because I usually have other things going, but then I was like, no, I know that causes lag. So let me see. I got to change that setting. It should be, I know it's like this. Damn, that's not it. Maybe it was like this. There it is. Okay. And like, be mindful that I am live streaming on my YouTube. It should be streaming. I got my notification, so it looks like it's working. It is a good idea to show your your full student name, so I don't have to search. Because again, that's how I'm giving attendance credit. I already have one person that's delaying the process. Let me check one more time. I think I remember it. There he is. Okay. All right, we got one more. And okay. Okay. So at the risk of like, just trying to keep your information private and being sensitive to your information, hopefully you can catch this drift. This is kind of a little joke, but Mr. Noah, just be sure to use your first and last name, okay, guys? So that way I'm not having to search and we can kind of honor everybody's time. If you have questions, just type them into the chat for right now. I think I'm going to mute it because I kind of want to focus. And I'll just monitor the chat. Right now, I'm just going to kind of like ignore the audio and just use the chat for right now for any questions that you have. And then I'll pause at different moments to address things that pop up. Like I said, I think we're streaming. I'm trying to think if there are any let's see, Ali Oxenfree, that looks good. Okay, I'm not gonna worry about it. Okay, as far as announcements, so let me see, who do we have? All right, so it's no major announcements that I can think of. This is our first full week. I know last week was kind of like orientation. I thought I let him in. Let's try this again. Got him, and okay, come on. All right. So let me see, there's no real notification updates. So again, the main structure for our course, now, this is online asynchronous. Hang on, guys are still trickling in. Okay. So the way I have my class, I don't know. Jeez. All right, I might have to lock this. But I mean, we're still within time, so that's why I'm letting everybody in right now. But I would like to get started. And again, it is a good idea to go ahead and make your display name be your student name, so that way, it kind of it's just more professional. This is supposed to be quote unquote professional. So now, again, the structure for our course, we're doing online asynchronous. So all I really need you guys to do on any given session is just like, once you get into the Zoom, that means you've gotten your attendance credit, right? You're not obligated to stay, because as the semester goes on, you'll see where just technical difficulties and stuff like that, it becomes a challenge. So that's why I do the asynchronous. So what I intend to do today, I'm doing the best I can with time. So this is week 2, but I'm going to go ahead and do the full lecture, the presentation for last week, where it was section 1.1, just the whole thing for the day. Let me see, I got this student, come on. So today I want to go ahead and do 1.1. It's a good idea to go ahead and subscribe to my YouTube. My YouTube is Beautiful Mind Pfeiffer. It's in our Blackboard. The links are there. Again, for right now, if you have questions, just type it into the chat. I'll be monitoring the chat. I think I got him. Yep. And yeah, they probably just got booted. That's okay. I'll be monitoring the chat. We are doing online asynchronous. So again, I do just need you to get attendance credit. These sessions are being recorded and live streamed onto my YouTube. So I try to make a recording. So this will be my official recording for section 1.1. I know that the one that I had before, the video wasn't showing, so that's why I'm redoing it. And I'm probably just gonna go through and redo them all. Is he still there? Did he get in? Okay, let me let this student in. So I mean, you know, it's okay. But let me go ahead and kind of get started with this section. It's a little bit intense. I'm going to watch the clock. This presentation might run a little bit longer than 50 minutes. I'd rather just touch on everything. You can always pick it back up next time, but I want to try to get everything in there. I'll watch the clock. You know, I'll honor the time. I'll let you go when it's time. But for right now, I'm going to go ahead and get started. Okay. How was I doing this before? Okay. All right, so it's a little bit of a lag, but we're going to go ahead and do this for right now. So this will just be the first, and like, so today I intend to do basically section 1.1 graphs of equations, and then later in the day I'll probably go ahead and do section 1.2. But again, I'm just going to stream everything. I might even get ahead in the lectures, but everything is streamed on my YouTube. Also, to access the homework, you access Pearson through Blackboard. Right, so the way it's supposed to is linked into Blackboard. So Blackboard is your one-stop shop for everything as far as our class. If you haven't already, I do expect that you purchase full access to Blackboard. It's about I think one of the students said it's about $105. But that's how we're going to be doing our homework, our weekly quizzes, and most of our exams, if not all, most of the exams. I see the chat going. Let me check the chat while it's a little bit early. You guys can't hear anything? Okay. Oh, that's not good. Let's go like this. Am I muted? I am muted. Okay. So I realized. Thanks, guys, for that. I think the audio did go out to my YouTube because I know that was working. So I'm going to kind of proceed. Let me just kind of do a quick recap. There are no real announcements, so this will serve as the presentation for section 1.1 graphs of equations. I know we're in week 2, so I'll probably do 1.1 graphs of equations now, and then later in the day, I'll go ahead and do 1.2. We are doing online asynchronous, which means at any given moment, I just need you guys to check in. So like how you did today, once you get into my Zoom, that means you got your attendance credit. You're not obligated to stay. But do be aware that these sessions are being live streamed onto my YouTube. Again, my YouTube is Beautiful Mind Pfeiffer. And for right now, I am going to kind of keep your audio muted so that I can focus. I want to kind of get through this presentations, and I will be monitoring the chat. So if questions or things pop up, just type it into the chat, and I'll periodically check that. Okay, thanks for that note that you guys couldn't hear me. Okay. So moving into what we'd like to get into today. This was a little intense. I'm just going to kind of do the presentation with my own flow. It is being streamed to my YouTube, so you can always go back, pause, rewind, slow down. You know, do things like you need to do in that form. Okay. So this is section 1.1 graphs of equations, and those are some of the objectives we'd like to get through in this section. Okay. So first, we want to kind of go through some definitions. Let me see. Is it lagging? It is kind of lagging. Okay, let me do something really quickly. It's gonna take. What do I have to do? I know I got to reboot stuff. Let me see if this fixes it. Hopefully it does. Yeah, usually when it lags, I just have to reboot. Either I have to like open and close the program, or I got to restart my device. Hopefully I don't have to restart my device because that takes up a lot. Okay, it feels a little bit better. Let me see here. Okay, that's better. Okay. All right. So a few definitions here. We have an ordered pair, right? So an ordered pair of real numbers is a pair of real numbers in which, let's go like this, in which the order is specified. For instance, if we have this like x comma y equals -3 comma 1, what this means is that the x coordinate is -3 and the y coordinate is 1, right? So ordered pair is just, shoot, let me get the student. Did I get him already, or is he in the next class? I think he's in the next class. Oh, no. Here he is. Okay, I got him. Come on. All right, I'm not worried about that right now. Oh my goodness. Guys, you come in late to our class, it's like, it's okay. And I got this one too. Cool beans. Okay, I think we're good to go. All right. Let's close that out. Okay. So the ordered pair A comma B has the first component A and the second component B. So again, an ordered pair is where basically the order is important, right? So the first number in the order is X and the second is Y. Okay. Yeah, and that'll you'll get used to that if you're not already. Okay, let's keep it going. So the set of ordered pairs of real numbers are identified with points on the plane called the coordinate plane or the Cartesian plane, right? So these X comma Y's, these ordered pairs, the X-axis is the horizontal axis going side to side. So you see the label right there. That's the X-axis, right? So say we wanted to plot 3 comma 4. We start at the origin, which is here, right? If X is 3, that means we go 1, 2, 3, and we're there. And then if Y is 4, we go up 4. 1, 2, 3, 4. And that's that point right there. All right. It's not that difficult. Let me see. Okay. So yeah. Oh no. No, we're not doing that right now. I had a game that was opening in. Let me see. We got a lot of latecomers. What's the time? I think I am gonna have to lock this thing. We still got like 6 minutes, so I'll let them in. We got 1. Come on. But see, it totally like slows things down. Come on. Okay. Then there's this one. Okay. And then this one. Man, we got like a packed house. And then this one. Cool beans. Looks good. Okay, I'm not going to worry about that. I'm going to let these guys in. Oh, and it says I had... See, yeah, this is why I do asynchronous. Because even on my end, it's saying that my internet connection is unstable. So I'm just going to have to do the best that I can with it. Okay, so let's just do some graphs here. Oh, so that slows this down. All right, yeah, I'm probably going to lock it at 15 because, you know, trying to take attendance messes everything up. So I probably will. Right now, especially if I notice like somebody coming in after 15 minutes, I'm just going to lock it and they're going to have to catch the recording. Okay, so let's keep going. So we refer to the points on the we refer to the point corresponding to the ordered pair A comma B as the graph of the ordered pair in the coordinate system. The notation P of AB designates the point P in the coordinate plane whose x coordinate is A and whose y coordinate is B. It's a little bit of a mouthful, but it's not that bad. I'm going to kind of leave this as an exercise because we'll be doing a lot of plotting and that doesn't take that much. So the distance formula. Recall the Pythagorean theorem states that in a right triangle with a hypotenuse of length C and legs of AB, then basically A squared plus B squared equals C squared. So now, in your notes, it is a good idea to go ahead, like either in the very front or the very back of your notebook. Hopefully you're taking notes because if you're not organized, what's going to happen is if you're not taking notes, when you go to take exams or anything like that, you're going to be like, heck, he did do that question. And then you're not going to have any reference versus this is kind of a game of organization. If you're neat, organized, if you're taking notes, then when you get on an exam, you'll be like, oh, wait a minute, he did that, you know. And obviously, if we're doing remote, you know, you can like flip straight to it. You see what I'm saying? Like if you're organized, because a lot of these things, it's the same questions just with different numbers, right? So as long as you're organized, you have things, you know how to find things in your notebook, you can quickly basically duplicate, you know, what you see and just like update it with the numbers or whatever. But yeah, so in your notebook, it's a good idea to have a formula sheet, and I don't even know who that is. Yeah, guys, try to be here on time or early. Let me see. I got them. This because the late thing kind of disrupts me. So yeah, just try to get here a little bit early and get your attendance. I probably will start initially. I probably start locking out the attendance. So we still got like at least 2 full minutes before I lock it. It seems like it's okay. Yeah, you just want to have a formula sheet. So every time we come across a formula, you want to update your formula sheet. So like if you had a section in your folder or your notebook, this is one of those formulas you want to add. I would write Pythagorean theorem for, you know, and put a squared plus b squared equals c squared and just have it ready to go. Maybe even draw the triangle. Okay. This is another formula, is the distance formula. So given 2 points P and Q on the coordinate plane, then the distance between P and Q, which is denoted by d of PQ, and we have the distance formula, right? I'm gonna spare you the details of where that comes from for the sake of simplicity. Just this is another formula you just want to add to your formula sheet. Okay. If anybody wants to know the backstory on this at another moment in time, I could notify you. But for right now, I think I'm doing the best I can to kind of keep it simple. This stuff can be kind of a little bit much. Okay. Oh well, this is essentially where it comes from. So 2 slides ago, we had the Pythagorean theorem given a right triangle, right? So say we consider some point P and some point Q, and we want to find the distance between P and Q, right? So then we can consider the right triangle set up in this form between these 2 points. So then we just said that for the Pythagorean theorem, a squared plus b squared equals c squared, right? But if we want the distance, if we want a, that's basically the change in y. If we want b, that's the change in x, right? And if we're trying to find the distance between these 2 points, that's... So then if we said this squared plus this squared equals this squared, that's essentially where this formula comes from, right? Let's see. Yeah. All right. Oh, I don't think he's here. Okay. I'll let him go. Let him in. Okay, I think we're okay. Hopefully it's not slowing me down. Okay. So you don't really need to know that, but the distance formula comes out of the Pythagorean theorem based on this image that you see on the left. Okay. So now in this example, we're asked to find the distance between these 2 points. Now, this is how I would approach this. A lot of this stuff is honestly repetition. What you do the longest, you do the strongest. Practice makes what? Hopefully you didn't say perfect, because that's absolutely wrong, right? Practice doesn't make perfect, practice makes improvement, right? As humans, we're designed for trial and error. So if you really want to be good at something, think about anything that you're good at. You're good at walking, talking, eating, using the toilet. What do? You do those things every day, right? I know the last one's a little bit inappropriate, but anything that you want to be good at, you do it every day. So if you want to be good at this, you got to do it every day, at least for like 2 or 3 hours every day. That's what it takes. I mean, there's no way around it. You can fudge and finesse and like get by, and that's another path, and there's nothing wrong with it. It just has its own set of challenges. In this game of life, I don't really believe in right or wrong. It's just these things are what they are, right? And you just kind of have to, quote unquote, act accordingly. So not to be on the soapbox or to drone on. Long story short, with math, if you want to be good at it, with anything in life, if you want to be good at it, you got to do it like every day, a lot every day, right? Whatever we do the longest, we do the strongest. Whatever we practice, we'll get really, really good at, right? If we practice complaining a lot, we'll get really, really good at it. If we practice making excuses, we'll get really, really good at it, right? But whatever, and so you have to make a decision. What do you want to be good at, and then just do it, And everybody has their way of doing things, but that's long and short. So the way I approach this. Every time, like for something like this, every time I use a formula, I write it down. So the X is to find the distance between the 2 points. So it is a good idea to at least have the distance formula ready to go. So the distance between 2 points, P and Q, that's going to be the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? That's the distance formula, right? Also, when I get an ordered pair, I personally like to just automatically label it, right? So I like to go x1, y1, x2, y2, right? So right off the rip, without even thinking, I see distance formula, I go ahead and label my points, x1, y1, x2, y2, and I write my distance formula, okay? So now, let's plug in and see what we have, right? So this is going to be equal to, now what's my x2? x2 is 3, minus, what's my x1? My x1 is -2. Notice I put the -2 inside its own set of parentheses, okay? What's my y2? y2 is -4. Notice the use of parentheses there. Minus my y1 is 5. All I did was plug in. Plug in as I saw it, right? Hopefully that's okay. Okay, so now we're back to arithmetic, right? So before you come into college algebra, that's why we have the lab component, okay? If we're feeling weak in arithmetic or anything of that nature, I'm watching the clock. We have supplement. We have support. Also, things that I just want to plant into your mind. You've already paid for tutors, right? Most students in college algebra, you need the tutoring, right? So it's available. I would say contact Dr. Clark and the head of the chair, the interim chair, something like that. Anyway, he's the chair for the semester, but just contact the math office and say, hey, I'm trying to connect with the tutors. If they're not already set up, they'll be set up shortly. You definitely want to take advantage of that, okay? Okay, let's go ahead and finish this out and get off the soapbox. Okay, so now, here we got, I'm going to work with my parentheses, right? So I have this 3 minus a negative 2. The double negative become positive. So then here, let me show that change. So then the double negative becomes positive. 3 plus 2 ends up becoming 5. So that becomes 5 squared plus, over here, we have negative 4 minus 5. Negative 4 minus 5 is negative 9. So I'm going to say negative 9 like this. And the squared continues, right? Okay, you should be able to take it from here. 5 squared is 25. Negative 9 times negative 9 is a positive 81. What is that? Is that 106? I think that's the square root of 106. Okay. I don't think that's a perfect square. It's not, because below it will be, the closest perfect square below is 100, and then the next one is 121. So I'm going to use that. I'm going to go like this. And let's just do it like that. That's fine, right? So my claim is that the distance between these 2 points is going to be the square root of 106. Okay, that's what I got. Let's compare to the notes, right? I like to start with a blank question. Okay. Yeah, this is fine for now. All right. So you see that we got our distance formula. Okay. Long story short, they got this, and then they took it a step further and found that approximation, right? So if you take the square root of 106, they got 10.3. Okay, let me pause for the cause. Hopefully we're not overwhelmed. Let me check the chat. All right, so let me kind of make my way through some of these questions. Okay, so we fixed the audio thing. Thanks for that heads up. We fixed that. Do we need to know definitions for exams? All right. The simple answer is yes, right? I'm going to leave it at that. Is the answer still correct if you only have the square root? Okay. So when the way I usually do my exams, like for instance, if the exam is on Pearson, it's going to be specific. It's like, okay, so for instance, later today, after I finish the lecture for 1.2, I'm going to work on the homework, right? So you'll see how I'll be working on the homework for you guys as well. But that's not, don't get too lax, because you still got to submit your own assignment, right? So I'm gonna do my best to get through as many of your assignments questions as I can. But you'll see, like, okay, in Pearson, they're specific. Hey, write a decimal to 3 decimal places, or, you know, it's specific about that. So these are good questions. And even on the final, I want to say it's like multiple choice, or it's very specific. So you don't have to worry too much about that. You know. And things can always be disputed. Like if you feel like you got something right, you can always contact me and we can sit down and like, okay, I can look at it, and sometimes, it's not clear, right? But yeah, it'll be clear about how it wants the answer. Right now, we're just trying to get this, introduce some concepts. These are good questions. This is good. I'm liking this. I don't know about you guys. I know online is a little challenging. I personally, I'm at home bumming. I just woke up. I woke up early enough to like be ready for this presentation. As opposed to if I had to come in person, I would have to get up like 2 and 3 hours earlier, fight traffic, eat. Like it takes so much more. Like I'm like, oh my god, and they don't pay me enough to get me there. Like I just, that's the god honest truth. I mean, I enjoy it though. I don't mind, but to be honest, like I have to eat, so it's like being able to be home is so much better for me personally. But I know it's a challenge, so there is value within person. It's a noticeable difference when you're like in the presence of someone and they're pointing versus dealing with technology. Like I see it. It's totally, I totally get it. But that's a discussion for a different time. And this is just me just venting. I can't stand when people say, "Oh, it's a shame they don't pay our teachers enough," but then nobody ever pays anything. I'm like, yo, if you really feel like that, pay something. Don't just give me lip service. That pisses me off. I don't be saying that to nobody, but I'm saying something here and I don't mind. But I'd rather like if you really feel like teachers need to be paid some more, just pay the teachers. Don't say anything. Just pay them. Like that's it. I know that's what I do. Like when I feel like somebody needs recognition like that, even like there's sometimes when I'm out and like I'm like, yo, y'all need to have tips. Like why don't you have tips? I just try to tip them. I try to tip them under the table. Uh, did I let him in already? But yeah, like if I feel like if somebody deserves something, I don't even say nothing. I just try to give it to them. Because I know about that lip service, you know, and I've worked in the service industry. Oh, cool. He left a message. That's awesome. Okay. Anyway, me venting, you know, just out here, just trying to have some fun and just being honest. But it's okay. So this is another formula that I would add to my formula sheet. This is the midpoint formula, right? The simple way I feel like to remember this formula, the midpoint between 2 points is basically the average of the x's, comma, average of the y's, right? So midpoint formula is the average of the x's, comma, average of the y's, right? How do we find average? We add up the components and divide by the number of components, right? Okay. So that's midpoint formula. So that's the third formula that if I had a formula sheet, I would add it there, right? So then when we look at this next example, we're asked to find the midpoint of the line segment joining these points. Okay. So if we're doing the midpoint formula, if the axis to find the midpoint, it's a good idea to use the midpoint formula. Let me see something. So I'm going to use a capital M for midpoint. Average of my x's will be x1 plus x2 divided by 2. Average of my y's will be y1 plus y2 divided by 2, right? That's the simplest way I know to remember the midpoint formula. Average of the x's, comma, average of the y's, okay? Also, when I get a set of ordered pairs, I'm just a fan of automatically labeling them. x1, y1, x2, y2. Again, you're going to notice a lot of repetition. Oh, okay. So I am going to have to switch to my Morehouse. For right now, so we got like 10 more minutes remaining in this presentation. I'm going to let Zoom boot me. We're going to get kicked off. I'm just going to get right back into the same account. Okay. So I'm going to let it boot us and then I'm going to just open it right back up. Okay. But that's like for another 9 minutes and 30 seconds. Okay. So now we want to find the midpoint between these 2 points. So midpoint is the average of the x's, comma, average of the y's. So then let's just plug in, right? So then the midpoint is going to be, so my x1 is -3 plus my x2, which is 1 over 2. And then my y1 is 6 plus 4 over 2, okay? So then -3 plus 1 is what? -2 over 2, comma, 6 plus 4 is 10 over 2. So that's going to be -1, comma, 5, all right? And also, these handwritten notes, I will make them available. Anything that you see me writing, I'll make it available for you all. So, you know, all these notes that you see me writing, you're going to get a copy of it. I'm going to create a folder, a box folder in Blackboard. I've been kind of holding out on Blackboard because it's still missing something. So I'm trying to get them to like make it available for me so I can get everything in order. But I'll make these handwritten notes available for you all. Okay, let's keep it going. And I'm watching the clock again. I might stream this stream might run a little bit longer than 50 minutes. I'm just going to do the full thing at a comfortable pace, and then you know you can always pick it back up later and finish watching the recording. Okay, let's keep it moving. So we got a result of 1, 5, right? And you see the same thing there. I think they did the exact same thing that we did, so I'm going to just let it be. Okay. So an ordered pair a comma b is said to satisfy an equation with variables a and b if when a is substituted for x and b is substituted for y in the equation, the resulting statement is true. So an ordered pair that satisfies an equation is called a solution of the equation, right? So given an equation, an ordered pair that's a solution is going to make the equation true, right? Any ordered pairs that make the equation true. Frequently, the numerical values of the variable y can be determined by assigning appropriate values of the variable x. For this reason, y is sometimes referred to as the dependent variable and an x as the independent variable, right? Because generally speaking, y depends on x, right? Given an x, you can find the corresponding y. It's, you know, that's generally how we do things. Okay, So the graph of an equation in two variables such as x and y is a set of all ordered pairs a comma b in a coordinate plane that satisfy the equation. Okay, so let's look at this example. We're asked to sketch the graph of y equals x squared minus 3, right? I don't want to give any backstory on this. I'm just gonna, now we have this equation, y equals x squared minus 3. These red x's that we have on the left, we just chose some values of x. We're gonna find the corresponding y values. All right, so we just chose some values of x. We're gonna find the corresponding values of y. All right, okay? So then for this first one, let's go like this. Y is gonna be equal to, we got our x squared minus 3, and we get a result, right? So let me do the following. We're going to be, so basically what I did, whenever I want to plug in for a variable, I replace that variable with a blank set of parentheses, right? As you see, give me just a moment. Let me just make this a little bit. Let's go like this. I'm just using the technology because I can. And then let's copy. Okay. So now in this first one, x is what? Negative 3, right? When x is negative 3 times negative 3 is a positive 9, so that's going to become 9 minus 3, which is 6. So then y equals 6 here, right? Okay. So then in the next one, when x is negative 2, so then negative 2 times negative 2 is a positive 4. I guess that might be a little bit better. Okay. And then 4 minus 3 ends up being 1, so y should be 1 there. Hopefully this is making sense. I'm going to go ahead and do the rest of them, just for the sake of time. So if you continue the pattern, okay. So then if x is negative 1, if x is 0, 1, 2, 3. Again, we just chose those values of x. So I got 4 minutes left. I'm going to keep going. Let's see. So then negative 1 squared is a positive 1. That's going to be 0, 1, 4, 9. Okay. The minus 3 comes down. And we get 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 4 minus 3 is 1. 9 minus 3 is 6. Okay. So given those red x's that we have on the left, we get the corresponding y's, right? Okay. 6, 1, 6, 1, negative 2. Okay, this looks good. So you see the ordered pairs, right? I think we're good to go there. So sketch the graph, right? So then if we plot those ordered pairs that we got, we'll get a graph like this right here. Okay, let me see the time. I still got like 3 minutes. And we're gonna go until 50 minutes. It's just because I need to switch over to my Morehouse. I just got to update things on Blackboard. So just you have to hang tight with me for right now. Sketching a graph by plotting points. So the first step is to make a table of the solutions of the equation. So that's what we just did. Given some values of x, we found the corresponding y's. Plot the solutions as ordered pairs in a Cartesian coordinate plane, and then connect the solutions in step 2 with a smooth curve. Okay. So then we have this definition. Any point where a graph intersects the x-axis has a form of a comma 0, and the number a is called the x-intercept of the graph. Similarly, any point where a graph crosses the y-axis has the form 0 comma b, and the number b is called the y-intercept, right? So we're talking about x and y-intercepts. In order to find the x-intercept, we set y to 0. In order to find the y-intercept, we set x to 0. Okay, let's see this. So in this example, we're asked to find the x and y intercepts of the graph of this equation, right? So I usually like to just get a copy of the original equation. So we have this y equals x squared minus x minus 2, right? Say I want to find the, okay, I'm going to start with, I prefer to start with the y-intercept. I feel like that's a little bit easier. If we want to find the y-intercept, then what we want to do is set x equal to 0, right? So if we set x equal to 0 and solve, we're going to get y equals 0 squared minus 0 minus 2. And that result is negative 2. So then the y-intercept ends up being 0 comma negative 2. Okay. Okay. So now say I want to find the x-intercept. Again, what we're going to do is set y equal to 0. Okay, those can be a little bit more, generally a little bit more challenging. Okay, I see we're about to get booted. Let me let this thing boot, and I'm going to jump back in. It says less than a minute. Hang on. Give me just a minute, guys. I'll be right back. Let me go. I think I can finish this one before the time runs out. I'll be right back. Hang on. So if we're going to set y equal to 0, okay, so then we're going to have 0 equals x squared minus x minus 2. Okay, 30 seconds. So hope. Oh, hang on. I'm just trying to let the time run out. So I'm pretty sure that everybody's not comfortable with factoring. That's the whole point of this experience, right? So that's why we have a lab, we have the tutors, but this one you'd have to solve by factoring. Let me log back into Zoom. I'll be right back. Hang on. 8, 7, 6, 5, 4, 3, 2. Are we still there? Let me see. I guess it's still going. I know it's going to boot us soon. Let me check the chat. Yeah, no. Did it boot? Okay. Come on. Okay, and let's share. We want to share this, share, boom. And then I'm going to go to view, admit all. All right, guys. We got about almost 10, maybe like 15 minutes remaining. So we're going to keep it moving. Okay. I'll let them in. Okay. So now, we want to find this x-intercept. We want to solve this equation. We have x squared minus x minus 2 equals 0, right? So I'm just going to do this one for right now. So we want to solve this with factoring. If you're not comfortable with factoring, I do have a handout. I have a whole chapter devoted to factoring in Blackboard. Also, the tutors are available to help with factoring because factoring can be very intimidating, but we have things in place to help address this. So with something like this, you want to start with a double set of parentheses. You got x and x, right? We're looking for two numbers that multiply to give us -2 and add to give us -1, right? I think it's what? -2 and -1. So -2, -1. -2, +1. All right. Notice that -2 times -1 is -2. -2 plus -1 is -1. Right. So that's how we know that those are correct. Right. Let's keep it moving. Okay. Okay. So now let me kind of label this. So first thing we did, we factored. Okay. Next, we want to use it's called the zero factor property. Zero factor property. The zero factor property says that when two or more things multiply to give you 0, either the first thing is 0 or the second thing is 0, or so on and so on, right? So when things multiply to give you 0, basically, long story short, set each thing to 0 and solve, right? So we're going to say x minus 2, we want to set it equal to 0, or x plus 1 equal to 0. Because if either of those is 0, it causes that above line to collapse to 0. So now if we solve those resulting equations, add 2 on both sides of the equal sign, so plus 2 and plus 2, x equals 2. Here, minus 1 on the left and right side of the equal sign, x equals negative 1, right? So then the x-intercepts end up being these two guys here. Okay, that's just for the sake of time. I kind of did it a little bit quick, but just trying to be cognizant of time. Let me let these gentlemen in. This wasn't too bad today. We got a solid 10 minutes. I don't know what that was about. Let me see. Oh, yeah. Okay, we don't need this. Close it out. Okay. All right. Okay, let me kind of keep moving. Let me take advantage of these 10 minutes. So all the stuff that we just did handwritten, we have it typed out here, right? So they found the x-intercept first, and I think they got the same results that we did. They did the same things. And then the y-intercept, they set x to 0, and then this is the graph, okay? All right, let's keep going. So symmetry. When you see the word symmetry, right, things that are symmetric, you can base generally like you have mirror images on about some kind of either an axis or a point, right? So symmetry means that one portion of the graph is a mirror image of another portion, right? So the mirror line is called the axis of symmetry or a line of symmetry. So we have some point P and some point P prime, and they're symmetric about this axis of symmetry, which means they're the same distance away from this axis of symmetry, okay? So then a graph is symmetric with respect to the y-axis if every point x comma y on the graph, if we're talking about y-axis symmetry, that means our x's change, right? So every point x comma y, we have the point negative x comma y is also on the graph, right? So notice with these 2 points, given some x comma y, if x goes from positive to negative, that point is also on the graph. So whenever that's the case, that means we have y-axis symmetry. For x-axis symmetry, instead of the x's changing, what do you think changes? The y's, right? So for every x comma y that we have on the graph, we also have x comma negative y. That means that we have x-axis symmetry, right? So for y-axis symmetry, the x's change. For the x-axis symmetry, the y's change, okay? And then origin symmetry, whenever we have x comma y, they both change, right? Okay, it's a little bit of a mouthful. I'll check the chat in just a moment. And origin symmetry means that we have symmetry with respect to the origin. So you have a mirror point opposite the origin, right? So if we drew a diagonal line through the origin, you're going to have points that are the same distance reflected, same distance away from the origin and reflected about the origin, right? Okay. So determine whether the graph of this equation is symmetrical with respect to the y-axis, okay? So if we want to do a test for y-axis symmetry, we need to, my abbreviation for change is a triangle. This is called delta. It means change. So we're going to change x to negative x, right? Again, this symbol, I'm using it to mean change. It's called delta, like the Greek delta, right? That's how I'm using it in this context, okay? So if we want to test for y-axis symmetry, we change x to negative x, and then if we get back the original, then that's a yes. If we don't, then it's a no, right? So let's start with the original. We have y equals, on bottom we have x squared plus 5 under 1, right? Now we're asked to change x to negative x. So here's my x. I'm going to change that in just a moment. We want to change x to negative x. Now we want to simplify. Notice that negative x times negative x, it goes back to positive x squared. Is this the original? Yes. We're back to the original. So then we would say yes, y-axis symmetry. Yes, y-axis symmetry. Okay, I'm going to abbreviate it and I'm going to go like this. Okay. Again, if you have questions, feel free to type it into the chat. I am monitoring the chat. I'll check it momentarily. I want to go for at least 3 more minutes. I'm going to let you guys go, but I'm also going to finish the stream, but I'm not going to keep you longer than 3 more minutes. So I think we have a typed version of what we just did with a brief explanation, and I think they essentially did the same thing that we did. Okay. So now in this one, we're asked to use symmetry to sketch the graph. So I'm just going to piggyback. I'm going to use the pre-typed notes for this one just for the sake of time. So if we start here, it says use symmetry to sketch the graph of this, right? So then the above box says test for all 3 symmetries. So if we want to test for x-axis symmetry, we change y to negative y. If we want to test for y-axis symmetry, change x to negative x. And if we want to test for origin symmetry, we replace both, right? So notice if we replace y with negative y, we do not get back to the original. So that's why that's a no. If we change x to negative x, we do not get back to the original. So that's a no, right? But if we change both x and y, we do get back to the original, and that's a yes, right? So then that means that we have origin symmetry. So origin symmetry means that whenever we have x comma y, we also have negative x comma negative y. So then what we can do is choose several values of x, and then you find your corresponding y. But then whenever we have these ordered pairs, we also get the reverse, right? So then when we plot those, we just chose several values of x, we found the corresponding y, we got this. But then with all these ordered pairs, we also have where if you switch both x and y, we get the mirror image of this graph. And when you put it together, you'll get something like this. Okay, we got a little bit more. I got a few more minutes. Let me keep you for a little bit more. Okay, I'm gonna use this as a moment to just kind of check the chat. I'm gonna let you guys go, but I'm gonna continue the stream. You're welcome to stay. It won't take me that much longer to finish out the section, but let me just check the chat really quickly. I think we're okay because I know we got booted. Okay, so let me see if there are any announcements. So my plan for the day, I'm going to go ahead and finish out this section 1.1. This is streaming live on my YouTube channel. I'm probably going to make a playlist with these lectures, right? Because this one I'm trying to make it clean so I can use it in the future. Also, I know we're in week 2, so later in the day, I probably will go ahead and do section 1.2 and get that ready to go. At least your homework should be available on Pearson. You access it through Blackboard. I'm trying to think if there's anything else. Exams start. I'll do my exams at week 4, 8, and 12, and then we'll have a final. Also be on the lookout for like weekly quizzes. They'll just be on Pearson. I haven't loaded them yet. They'll be quick, like no more than like 5 questions. It should be quick. And then basically the quizzes are going to be similar to how the exams are going to go. But it'd just be fewer questions. It'd just be like a couple of questions. Okay, if there aren't, I can't think of anything else that's pertinent. If you have questions, feel free to type in the chat. If you don't have any questions, enjoy the rest of your day. Take a breather. Okay, I know this stuff is intense. Go eat some food, take a nap, get some exercise, play a video game. I want to share something with you guys on this video on how to achieve any goal. I'll make it available for you. I gotta think about it and remember. But yeah, just rest. And then once you feel rested and refreshed, sit down with the stuff and start making your way through the homework. All the homework for the semester is available. I do intend to make all the quizzes available. The only thing I don't want to put in advance are the exams, right? Those are going to be open for a limited time for like 5 days, closer to the weeks 4, 8, and 12. Okay, if there aren't any further questions, I'm going to let you guys go. I'm not going to keep you. I'm going to go ahead and finish out this section. It might take me maybe another 10 or 15 minutes. Again, this recording will be available on my YouTube channel, okay? Okay, guys. See you Wednesday. See you Wednesday. Okay. So, continuing with this section. So we have a circle is a set of points in a Cartesian plane that are at a fixed distance r from a specified point h comma k. So r is going to be called our radius. That's basically the distance from the center to the edge of the circle. And then the point h comma k is called the center of the circle. All right, so we're calling the center of the circle h comma k. Okay. So the graph of a circle with center h comma k and radius r, it looks something like this. Okay, it'll, we're going to be exploring things of this notion. And the equation of the circle you see at the bottom, this is another formula I would add to my formula sheet. I would just call it equation of a circle. I think this is like the standard form. You got this x minus h squared plus y minus k squared equals r squared. You definitely want to just have that available. Again, the equation of a circle with center h comma k and radius r is given by this. This equation is also called the standard form of the equation of a circle with radius r and center h comma k, right? So again, this is called the standard form. So we're asked to, in this example, we're asked to find the standard form of the equation of the circle with this center and this radius, right? So again, like before, every time we use a formula, it's a good idea to write it down. Okay. So the standard form of the equation of the circle, let me see. I think it was x minus h squared plus y minus k squared equals r squared, right? Let's see, the center. So if this is the center, that means, as far as our formula goes, this is our h, whoops. This is our h, and this is our k. And this is our r, right? We want to label the different components accurately, right? So we're asked to find the standard form of the equation of a circle. So we want to finish with an equation. So what's our h? Our h is -3 plus y minus our k is 4 and our r is 7, right? And just a little bit of simplification. Double negative becomes a positive, so that becomes x plus 3 squared plus y minus 4 squared equals 49. This is going to be the standard form of the equation of the circle. Okay. And I'm talking at this pace because it's a recording, right? Because we can always go back, pause, rewind, slow down. Again, it takes time. I know we don't have a lot of time. So I think that the moves that Morehouse made as far as college algebra, I think it was a move in the right direction because honestly, section 1.1 would have just been one day in the past, and then 1.2 would have been the next day. And it was totally overwhelming most of the students. And the struggles with college algebra is not Morehouse specific. It's like nationwide, if not worldwide, right? So I felt like dialing back some of the content material for the students was a step in the right direction, just because it can be a bit much, to be proficient. It's kind of like the technique of taking one step back and 2 steps forward. Okay, and I think they got the same thing that we got. Okay, so we're asked to graph these equations. Let me think. What are the techniques that we're using here? I might piggyback. What did we just do? Oh, okay, these are circles. Okay, no, we're good to go. We're good to go. Okay, so these are equations of circles, right? So let's start off. Let's get a copy of the standard form of the equation of a circle. Standard form. Let me think about this. Actually, these are already in standard form, right? For instance, if we look at part A, x squared is the same as x minus 0 squared plus y minus 0 squared equals 1 squared, right? So in this form, you can see that the h comma k is going to be the origin, and the radius is going to be 1, right? So basically, you would have a circle centered at the origin with a radius 1. That's it. Let's go ahead and do part B. I'm not going to sketch it. I just want you to get the concept. This one is already in standard form as well, right? So in part B, we just need to put it in the proper form though. Because remember, it's supposed to be x minus h and y minus k, right? So because we have x plus 2, we need to rewrite that. It needs to become x minus -2 squared. The second one is y. That one's already in the proper form. And then we need to rewrite that. 25 is what? 5 squared. Right? So now in this form, our h comma k is going to be -2 comma 3, and the radius is going to be 5. Okay. I know these aren't the graphs. I'm just going to use this because once you have this, the graph is simple from that point. It's not. It may or may not be easy, but it's definitely simple. The origin, the center is at the origin at radius 1. Let's copy and paste. Come on. Thank you. Yeah, you gotta talk nice to your technology. If you call it stupid, it responds to that and it behaves. It's like basically what you get what you expect. So if you expect it to be stupid and behave poorly, that's what it does. But if you kind of be gentle with it and treat it like a conscious being, I know it sounds kind of silly, but it actually works. Like you got to be patient and it helps with everything. Okay, so the second one for part B, the center is at -2 of radius 5, right? So then part A, the center is at the origin with radius 1. Part B, center is at -2, 3 of radius 5. Okay, we're almost done. The general form of the equation of the circle is given by this, right? It wouldn't hurt to add this to your formula sheet, right up under the standard form of the equation of a circle. And all that happens is they expand the standard form and then just put it in, arrange it like this, right? So find the center and radius of the circle with this, right? I might need some more space. I'm going to try to work within this space for right now. All right, let me start by getting a copy of the original. So we have this x squared plus y squared minus 6x plus 8y plus 10 equals 0, right? So this is just a copy of the original. We're asked to find the center and the radius of the circle, so it's a good idea to get it into standard form. So I'm going to show you how to get this into standard form, at least one way. So first I'm going to rearrange. I want to put my x's side by side, so I'm going to highlight my x's in like blue. All right, boom. And my y's, I'm going to highlight them in green. I want to get my y's side by side, right? So if we group the x's, we'll get x squared minus 6x. I'm going to leave some space. If I group my y's, we're going to have y squared plus 8y. I'm going to leave some space, and I'm going to move that 10 to the other side. I'm going to subtract 10 on both sides of the equal sign, and we'll have -10 on the right. Okay. So now we're going to use a technique called completing the square. All right. I'm going to make a note here and call it. Next, we want to do completing the square. Okay. So for instance, for the first one, the b is going to be -6. So completing the square, we want to do negative b over, what is it? Wait a minute. We want to say b over 2 squared. I think it's just b over 2 squared. I think it's b over 2 squared. Right there. We also want to do this one. B over 2 squared. And what we do on one side, we have to do on the other. So let me be a little bit more precise with my colors. I can use orange, right? So if we do the purple and the orange on the left, we also need to do purple and orange on the right. All right. So let me get a copy of these guys. Copy and paste. All right. So if we did it on the left, we also need to add these components on the right. Okay. So now let's account for those changes. So the x squared comes down, the -6 comes down. So now our b is -6. So we're going to say plus -6 over 2 squared. We're also going to do it over here. Plus -6 over 2 squared, right? And then if we keep going, the greens come down. And now in this one, our b is 8. So we're going to say 8 over 2 squared on both sides. 8 over 2 squared, right? And then let's bring down everything else. Okay. So now, -6 divided by 2 is -3, so that ends up becoming a 9. Okay, so this is a 9. This one is what? 8 divided by 2 is 4 squared is 16. Again, this is 16. This is 9. This comes down. I'm just bringing things down. I think I can get it to fit. I think we're almost there. I was totally about to make an inappropriate joke. Anyway, okay, so now completing the square. If we look at the blue and the purple, we can factor the blue and the purple, right? So if we group the blue and the purple, it'll factor into x minus 3 squared. Okay, that's factoring. The next part factors into, if we look at the green and orange, it becomes what? Y plus 4 squared. Okay, so completing the square is one of those things you want to you got to get some help with it. Y plus 4 quantity squared. Okay, and then on the right hand side, negative 10 plus 9 is negative 1. Negative 1 plus 16 is 15. Is that right? Yeah. So then the R is going to be, so the center, okay, and we kind of do need to do a little bit more changes, but I'm going to go ahead and write the result. The H is going to be 3, the K is going to be negative 4 for the same reason as before, and the radius, hopefully I didn't make any mistakes, is going to be the square root of 15. Okay, so we got that center and that radius. All right, so it's a little intense. I would definitely take this and link up with the tutors, okay? Um, we can potentially have time during class. You're welcome to like attend my other classes as well, because I'm going to kind of be doing different things with all the classes, so that way it's not monotonous for me, and I know the stuff is going to be available for you all. Okay, we got 3 comma negative 4 and a radius of root 15, and that's what they got there. Okay, and I think that was it. So, you know, you have to do your best. Don't be intimidated. I mean, it's okay to be afraid, but unless that fear is serving you, I wouldn't use that energy, right? This is not the realm for fear. You can just use the fear to be cautious and to be aware, but don't use it to be paralyzed, all right? Don't give up. It's intimidating at first, but once you get into it and you start getting your reps in, it gets easier to a degree. You start to, you don't get fooled by the same things twice. You know, that's kind of like the long and short. Okay. All right. So it was only 10 more minutes for what I wanted to do. Let me see. I don't know if anybody's still in the. Let me see. Let me check the Zoom real quick. Okay, so I am the only one here. That's fine. I can't think of there. I don't think there's anything else that I wanted to share as far as this content, but that is a full lecture for this section. I will be. I do intend to be doing sections 1.2 later today as well. Okay. So with that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.